Sierra Nevada is a privately owned company, and we specialize in aerospace systems. We have a very broad portfolio. The Space Systems Group is one of 6 business areas within the company.
We have been in the space business now for 26 years, over 425 missions, and we have built over 4,000 things for space. And during that entire time, all of our products have worked on orbit, so we've had a 100% mission success rate.
We are pretty unique in the industry in that we build components for almost every major satellite manufacturer and launch vehicle provider in the world.
Dream Chaser, we're building a manned vehicle to do the exact same job that the space shuttle did.
We are designing this vehicle from the ground up to be serviceable, to be refurbishable in a low-cost manner.
With a lifting body, you can launch and land anywhere in the world. You have a low-G re-entry or a gentle re-entry where you can bring back sensitive science, and it has applicability to science missions and all kinds of other activities in low Earth orbit that a capsule doesn't.
One area that's become very important is the idea of something we call the global project, and that is being able to take Dream Chaser, a rocket launch, all the training that's necessary and all the support necessary, and tie it up into one package so that a country who doesn't have a space program could actually get a space program. And it's really enabled by the virtue of creating this large global partnership that we've been able to do, and in part having Siemens as part of that package.
We're competing against some of the giants in the aerospace industry. We have to show that we have the same level of sophistication in our engineering capabilities, in our design tool sets, in our ability to integrate with NASA, our ability to integrate with partner companies all across the world.
We're trying to build a Dream Chaser at a fraction of the cost of what the space shuttle cost. So to be able to use software like Siemens, CAD software, simulation software, some of the motion software we're using, and be able to simulate it accurately and confirm that we have a good design, that it's going to work, and then be able to go straight to build saves us huge amounts of time and huge amounts of money.
Dream Chaser is a very, very complex vehicle. And just to capture the design and all the internal functions of the vehicle requires a huge amount of data. And the amount of time and labor that we were wasting waiting for files to open, trying to check files out, trying to get the work done, was costing us a lot of money. We've benchmarked various software packages. We were running sample scenarios of very large files to see what kind of time savings we thought we could get. When we moved to the Siemens tool set, we're seeing between 20 and 30% improvement in the times to access files.
One of the things I love about NX routing packages, both electrical and mechanical, is that you can just pick a point on a surface. In other CAD programs, you had to define 6 datums in order to define that point. And in NX, you just go, put it there, and it does it, and it figures out all the math behind it, and you can just continue routing away.
One of the strengths of using NX is that I can rely on the arrangements within the CAD and use those to key off my FIM, so I can have a single model that has a bunch of different arrangements and different load cases that are applied within that. The other complexity is just the sheer number of parts and the different assemblies. I don't have to worry about managing data and transferring data through step files manually.
So it's not only savings in times that we experience, but most of our partners also use Siemens tools, so we could probably save months worth of time over the life of the program. It became very easy for us to collaborate from day one with all those partners because we use a common tool set, we talk the same language, and we're able to do a collaborative development.
With an all-composite vehicle, you can actually build and construct using composites complex curvatures like the outer mold line of Dream Chaser that allows it to fly back from space to the ground very effectively.
One thing I like about NX is that it's very powerful at handling complex surfaces. And our vehicle, as you can see, has a ton of really complex curves coming into other curves. And NX allows me to take section cuts through the vehicle, and I can see exactly what's going on at any point in the vehicle design to make sure that nothing's going to interfere.
NX simulation tools are used on Dream Chaser to generate basically simplified geometry, moving into the FIM or the finite element model, and then finally into the simulation side. And in the simulation side, we can analyze anything we want to, any operational environment. We can apply thermal loads, mechanical loads, pressures, and then run them through different solution series sets and look at both strength and stability. I just use NX for pre and post processing, and then we also use Nastran for the actual solution set. And we also use NX Advanced Simulation.
By having a good quality product like NX, where we can do detailed design and get it right the first time, it's going to give us a better product. So we'll be able to deliver to the customer on time or ahead of time, on budget, and exceed their expectations.
When we fly the first time, it'll be the first time that we ever do this and it comes back through the atmosphere. We better get it right. And that's why we have to have confidence in the Siemens tool or any of the other tools we're using.
Working as a team together, we can produce a product that's much greater than the sum of the individual companies.
There's a reason why so many people are using the Siemens products, is because they work and they're very effective.
They see us as a partner, and I've grown to see them truly as a partner.
One of the things we found about Siemens and its software is it's really terrific way to be able to be open architecture and integratable with the many other different platforms that we've used, and that's why we continue to look at it as something that's considerably part of our future.